Okay, so this is the review for the first 3 lessons of Chapter 2. Number 1, we are going to graph it. This is in vertex form. Remember, we wanted to find a few things before we graphed. So the first thing I wanted to do was find the vertex. And of course, that comes from this number and this number, right? So the vertex for this one is going to be negative 3 and 4. If you recall, we talked about in class how when you pull out of that parentheses, it's always the opposite. Go back and look at your notes. Which would then make the axis of symmetry x equals negative 3. Remember, it's the same as your x value of your vertex. Now for the y-intercept, I'm going to have to do a little bit of work. For the y-intercept, remember what we did is we said we know x has to be 0, right? Because it's the point 0 and something. So I'm just going to take 0 and plug it into my equation, 0.3 squared plus 4. And you get 13, which means the y-intercept is 13. Okay, so that's just the basic information you need to go graph it. I'm going to come down here to my graph paper. I do need a tall graph for this one. There we go. Because I do have to go up to 13. I'm going to make sure and make it tall enough, I hope. Okay, so let's start with, we know that the axis of symmetry, the axis of symmetry is at negative 3, which is right 1, 2, 3, right here. Straight lines. Ta-da. Okay, so that's the axis of symmetry. Remember how we talked about you don't have to draw that if you don't want to, but it's very helpful for me. All right, the vertex is at negative 3 and 1, 2, 3, 4. So there's the vertex. And then my y-intercept was at 13. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13. So here it is. And then we know, again, since the yellow line is the axis of symmetry, that there's also a point on this side because it does indeed have to be symmetrical. And that's it. That's the 3 main points. We need to just get a general sketch of our parabola. I do apologize that this is kind of a wonky parabola. Oops. And there we go. So that's number 1, graphing in vertex form, very simple. Number 2, what steps transform the function? So we see here that there's a negative in the front. If there is a negative in the front, we know that it is being reflected. So this is a reflection. This would be if I graphed this one, like the last one was face up, this one would be face down, right? It's a reflection. Again, this is the H and this is the K. So I know this would actually be a negative 3, right? So it moves left 3. And then from this, we know it's going to go up 5. So those are the steps of transforming it. As it reflects, it moves left 3 and then up 5. Number 3, the vertex in the axis of symmetry is super duper easy. Again, for the 3rd time, this is H and this is K. We're going to make sure and be careful with that. For this particular question, this 2 doesn't really do anything. Like, it does dilate the parabola to actually make it a little bit skinnier, but we're not asked that in this, so don't let that particular 2 trip you up. We won't actually be using it for this question, so you can just kind of ignore it for what we're being asked for number 3. So the vertex is the point negative 2 and negative 4. Remember, this is going to become a different sign, and this is going to stay what it is, negative 2, negative 4, which would then make the axis of symmetry x equals negative 2. Again, it is always the x coordinate of your vertex. I'm going to come back to number 4. If you recall, we did not get to that one in class because the Wi-Fi died, and that will be a bonus question. Come back to it in a minute. Number 5, the vertex in the axis of symmetry in standard form. Sorry, so the vertex form, graphing in standard form. Now for not graphing, graphing's number 6. We want to find the vertex in standard form. So the first thing we have to do actually is we've got to find the axis of symmetry. Remember we had that formula, negative b over 2a. Here a is going to be negative 2 and b is 8. For number 5, we don't need c, so it is negative 20, but we're not going to need it. So the first thing I'm going to do now is put this in. So it's a negative in the formula, and 8 is b over 2 times, and then a is negative 2. So that's going to give us a positive 2 for the axis of symmetry. So we have half of our answer. The axis of symmetry is x equals 2, right? So that's That's a really important part of our answer. Now we're just going to take that 2 and we're going to put it back into the equation for our x's, and we're going to work that out. So I would do negative 2 times 2 to the second plus 8 times 2, and then minus 20. Again, we're just putting it in for the value of x's here and here, and I'm using this 2 that I got from my axis of symmetry. So when I plug that in and I work that out, I do get negative 12, which means that the vertex is the point 2. So that was our x value, and we just figured out our y value was negative 12. So that is the second part of our answer for number 5. Number 6, we're going to pretty much do the same thing, except for we're going to graph this one. Okay, so I'm going to start off with the same equation. Now this time a is 1, b is negative 4, and I do need the c for this one. C is 5. And I'm going to do that formula again. Now this time, notice how your b is already a negative 4, and there's a negative in the formula, so be careful. It's negative 4 over 2 times 1. So that's going to be positive 2 again. Okay, so again, our axis of symmetry for number 6 is x equals 2. And then just like last time, I'm going to do the same thing. I'm going to go take that 2, and I'm going to plug it into the equation. Excuse me. So that I get 2 squared minus 4 times 2 plus 5. And I believe you get 1 for that. You do, you get 1. So that means that my vertex is the point 2 and 1. Now one last piece of information, let me highlight these two so that I can keep up with what's important. So that's important, this is important. We're going to go graph those. And then the last thing is we do need the y-intercept. That's going to help us out a lot. And if you remember, we talked about how to find the y-intercept, and we come to the conclusion that basically it's just your c value. So the y-intercept here is going to be the point 0 and 5. So that's our last really important piece of information here. And once you have those 3 things, then we can go graph them. So I'm going to go back to my graph paper. Now this graph is not going to be large at all, so I don't have to make it as tall as I did the last one. Oops. There we go. X, Y. Ooh. All right, now this time our axis of symmetry is at the point, or excuse me, at x equals 2. So that's going to be here. There we go. X equals 2. Our vertex is the point 2 and 1, so that's going to be here. And then our y-intercept is at 5. So 1, 2, 3, 4, 5, that's going to be here. Now just like last time, whenever I was graphing, we used that axis of symmetry. So we know there's also a point on this side of the axis of symmetry. And that's pretty much it. Like there's my really not beautiful. It's very difficult to graph on this glass. Okay. All right. So that's the parabola there for number 6. Number 7, you are factoring. I wanted to make sure you remembered all of the fun factoring we did. So remember, you're going to take and you're going to list the factors of 48. I'm going to do number 7 down here. So the factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Those are all of the ways you can multiply to get 48. Remember, what you're looking for is that you're trying to find the pair that will either add or subtract to the middle number. In this case, obviously we know we're adding, everything's positive. And that, of course, would be the 6 and the 8. 6 plus 8 is 14. So that's going to factor into x plus 6 and x plus 8. Whereas number 8 is also factoring. We just have to keep in mind that now we have a 5 in the front. So whenever I go ahead, I'm going to go ahead and start writing my answer before I start my factors. It has to be a 5x and a 1x, because that's the only way you can multiply to get 5, right? 1 and 5 are the only factors of 5. It's a prime number. Now 15, I could use 1 and 15, or I could use 3 and 5. Remember, what you're going to do is you're going to strategically place those in the binomials so that whenever you multiply, you're going to get an add, or in this case subtract. You're going to get a negative 22. So we decided in class we would put the 5 here and the 3 here. And remember why, let me explain real quick. It's because 5x times 5 is 25x. And 3 times x is 3x. And we know if we were to subtract 3 and 25, that's going to give us a negative 22. Now we do have to be careful though. Like, I need my 25 to be negative because I need it to be a negative 22. So I'm going to make sure and put a minus sign here because 5x times negative 5 is negative 25. And a plus sign here because 3 times x is a positive x. So my answer is this. This is my answer. It's the factored form of number 8. And then the last one, number 9. Here it's just asking about the factors. Remember how we talked about whenever we have a quadratic in factored form, which we don't here, right? We talked about, you know, if we factored that, that would be y equals x minus 8 and x minus 2, right? Just like how we factored back on number 6. And it's saying, what are the zeros of the function? Well, the zeros of the function, we could look at the graph here, are at 8 and 2, right? That's the zeros, 8 and 0, and 2 and 0. Those are our x-intercepts. And then I ask, how do the zeros relate to the factors of x squared minus 10x plus 16? And we can see here that that the factors are the zeros, right? We get the factors from the zeros. And that's number 9. Now I'm going to go back to number 4 because I promised I would. Now on the quiz tomorrow, it will be a extra credit problem. So if you took the time to watch this, then there you go. Here we go. So you do need to go to Desmos. So let me do that now. And we want to put in a table. So remember to do that. You hit the plus sign, go to table, and I'm just going to type in the numbers there on the table. So weeks are 1, 2. What's nice is it recognizes I'm counting by ones there, so all the way to 6. And then for the other ones, we get 600. I'm just typing in the table beside number 4. If you look, this table says that it represents population of waterfowl and the different weeks. So what we're going to be doing is we're looking for a pattern to see if there's a relation. And okay, so there are my points. Now obviously I can't see them, right? Because like my y values are huge. Right? See, if I can zoom in, there they are. There's my y values. Now what I want and what it's asking for, if you look at the problem, it says use graphing technology to find a quadratic regression. Okay, so let me go back to my notability here for a second. So we wrote this on our notes. If you have the paper we did, I believe it was last Friday. This is the quadratic regression formula that you're going to type in. I'm about to type it in to Desmos, but I wanted to write it down just so you could see what I'm typing in. And this lets Desmos know, hey, this is a quadratic. Can I please have the equation? Remember when you go to type in the ones, you're just going to type the number 1 and it automatically makes it a subscript. Okay, so again, that's the quadratic regression. So that's what I'm about to type in here. So y1 and then the tilde, a x1 squared plus b x1 plus c. Get all my letters in there. Okay, so you can see that it does graph it. It's really difficult to see. Honestly, you don't need to see the graph, but I want to see it. Look how our x values are basically from 1 to 6, like they're really small. So I'm going to take and change my window so that it shows me like, I don't know, I'm going to go, like from negative 20 to positive 20. There we go. And so see how much nicer that looks. Now we can go, oh, look, yep, there's the parabola, and it's a better view of the window. Okay, what they ask for are what's the equation? So look down underneath our thing. Let me screenshot it here. There we go. So I can write on it. So look down here. Look down here. Look at this, right? Here it tells us what A, B, and C are in standard form. So if you look at your paper, there are 2 of them that have A is 25, so we know it's going to be y equals, or a p of x is what they used, which is fine. If you remember how we talked about function notation and y, the same thing. A is 25, x squared. B is negative 25, x, and then c is plus 600. Okay, so that's our actual equation. I don't need that anymore. So let's go back and look at our problem. So that means we know the answer has to either be this one or this one, right? Those are the two functions, so it's not B or D. We want to use the model to estimate the number of waterfowl on the lake at week 8. So that's where it's saying, okay, is it 2,000 waterfowl or 1,650 waterfowl? So week 8, that just means, you know, if I kept going and said week 7, there were this many, week 8, there were this many, that's what we're looking for, is what approximately should be the number there. We're using this regression model to make a prediction. So all you're going to do is you're going to take an 8, right, because that is our x value, and you're going to put it into that equation. And I really need some more room. I'm going to scoot back here. I'm just going to stick it right here in this random spot here. So I'm just going to put 8 in. So in my calculator, I'm going to do 25 times 8 squared minus 25 times 8, and then plus 600, just like we did whenever we were finding the vertex, for example. I mean, that's really all you're doing. So I just plugged it in, and you work it out, and you get 2,000 for this one whenever you work that out. So the answer is C. At week 8, according to this regression model, there should be approximately 2,000 waterfowl at that lake.